Hello everyone, be welcomed to this short video again in Easy Geotech. In this short clip I will show you how to import a Leapfrog block model into Midas GTS-NX in order to obtain a fully mesh based on the block model from Leapfrog. So let's begin. In the last update of Midas GTS-NX, they included a very useful module called Mining Model Converter. It basically gets as an input the mining mesh triangulation or this typical triangulation from mining software from scans, and so basically the software Midas GTS-NX is able to adopt in two forms. The first one is the 3D phase, which is basically like an outer shell of the model with nothing inside. That's why it's a shell, a 3D shell. And the software reads this shell and converts it into a finite element mesh, which needs to be converted in 3D afterwards. This is the procedure, how it works. And the second method that they implemented is a block model method. The block model is, that typical arrange of cubes with the centroids, and this software is able to read those data in a typically in CSV file, and you then can import it into GTS-NX. And the block models can come from Leapfrog, like in this example. And we are going to convert the block model from Leapfrog to a block model to GTS-NX. So let's begin. So here we are with our block model exported from Leapfrog Geo. As you can see, there are some comments in the beginning of the CSV file with some general information about the block model, the block size, and so on, the centroids. And here we can see that we are selecting several kind of lithology that this model has in it. So as you can see that all the blocks measure 20 meters. So these are all the lithology and geology included in the model. So now, in order to import this into Midas GTS-NX, we need to select this part and remove it, delete it. Delete this part, and then you can export into Midas GTS-NX, and there is no need to move any rows or columns of it, and the model will be ready for it. As I told you in the beginning, in the last version of GTS-NX, they implemented the mining module. So now I will explain how to import the block model into Midas GTS-NX. So here we are in Midas GTS-NX. We just need to press the main button and select the option, click on the option Execute Mining Model Converter, the circle green area. And by pressing so, we will obtain this new window, and where the arrow is pointing, we need to select model blocks, since we are importing a block model from Leapfrog. The second option there in that label is the option related to the phases of triangulation. We can try to do it in a different example other day. So yeah, we just need to browse the location, the path of the block data, and select the path of the output of this process, and press the button convert. Depending on the size of the model, this can take a couple of minutes, but it's quite fast in any case. By doing so, we will generate a file called .fpn model, and this is it for now, and we need to import this later on, this generated fpn file, into my GTS-NX. So here we are with GTS-NX. So we are going to import the neutral GTS-NX neutral format, which has extension fpn. So we import it. The software is reading the block model, and here's the block model with all the meshes with the name according to the names set in Leapfrog: Miss GND, QSP, etc. etc. We can quickly explore the model by using the clipping plane, and we can see how the YOLO actually is, and that's it. Well, there's something fascinating about this model, is that if we go to mesh panel and go to materials, we see that all materials are already set, obviously with no right numbers of geomechanical parameters, because Leapfrog is not a simulation software, but you just need to edit those values. And the same from properties. In the property panel, we have all the solid and the kind of properties already set. So property with the right material, so everything is matched completely, and this is basically the tutorial. So now the model is completely ready to be modeled. In fact, if we go to static slope analysis, we can set self-weight, and we can set the constraint, the boundary conditions. We put auto. Here we are ready to simulate. If we have some lithology with a certain name, we can deactivate mesh sets, and that's it. I hope you found this tutorial useful. So thanks for watching. If you like my content, don't forget to subscribe and share the video. See you next time. ECU Tech out.